Right, good morning, everyone, and happy Friday. So, today we're going to carry on with elimination. In our conference on Wednesday, our live conference, we went over the basics of elimination. We're going to go over just a little bit of that today before we go into some more complex problems. So, still, we need to know how to solve using the substitution method because for the second half of this, we're still going to substitute in, and we'll see what that means a little bit later. You're going to become the eliminator. Um, so we have a handful of steps we're going to follow for the elimination method. You'll be able to identify what you need to do to be able to cancel out one of your variables, and students can solve multi-step equations. Just real quick, something we want to make sure we remember that a solution to a system of equations is the x and y value that make both true at the same time. Remembering that that is what we're finding, and this will come in handy a lot like when we're doing story problems, when it makes a little bit more sense than just with variables. We're not doing those today, but just remembering that the solution to a system's equation is when both of the equations are true using that x and y value. So basically our whole goal with elimination is to cancel one variable out. So basically we just basically need to identify more or less if I have -3, what do I have to do to cancel that out? What do I have to add to cancel it out? If I have -7, what do I have to add to cancel it out if I have 4? So pause for a second and try to figure this out, all these real quick in your head. All right, so we have 3 here. It's -7 plus 7 is 0. 4 and -4. -5x and 5x. 3x and -3x, and -4y plus 4y cancel out. So go ahead and pause real quick, double check that you got those at all that makes sense. But the basic concept we have to do today is figure out, what do I have to get these to be for them to cancel out? I'm always thinking, how can I cancel one of these variables? We might have some, so let's look here. Our steps for elimination. Well, first we're going to check, do things cancel off right off the back? -3x plus 3x, that would cancel out. So I don't have to multiply anything. Does that make sense? -3x and 3x, I think we might have actually seen that here. 3x and -3x, right? We know that those added together are going to be 0. So if that's the case, I simply add both of the equations together. Plus 5y equals 14. Then we'd solve for the variable. Divide by 5, and we'd get y equals 14 over 5. Then we would plug that back into the equation, and we would find our x value. That's for substitution. So our steps are, we check. We would multiply this by something if we had to. We didn't have to. Then we add right down the line. We add the numbers, the x's and the y's. So our equation should be in standard form for this. And then we solve for the variable that's left, and we substitute that variable back into the equation to solve. So let's take a look right here. Our steps are still up in the top corner. If I add 2x and 2x, it's not going to cancel out. If I add 4 and -2, it's not going to cancel out. So this is a situation, I'm going to have to multiply one of these equations by something. I want you to think real quick, see if you can think, what can I multiply that by to get it to cancel out? You should probably figure it out if I multiply it by -1. -1, and I have to distribute that to every number. I'm going to rewrite my system of equations right here. 2x plus 4y equals 22. That's the same. Now, I multiplied everything on the bottom by -1. So negative 2x plus 2y equals 8. So all I did was I multiplied everything by -1, so I flipped the signs in front of it. I multiplied it by something that will make it cancel out. Now I add all of this, and I add right down. This gets added, and this gets added. So 2x plus -2x is 0. Plus, so I don't necessarily need to write 0. I just did it to fill space. 6y equals 30. Now I divide by 6. Divide by 6. Y equals 5. So this is the only problem here that's not on your homework. But this is just a quick review. We did this one together. This was actually on your homework on Wednesday. Now we have y is 5. Now, that's step 1 we did. Step 2, we added the equation. Step 3, we solved. Now I substitute y is 5 into either equation. I'm going to put it into the top equation. And all I do when I substitute it in is I put 2x plus 4 times 5 equals 22. Now I solve this equation. 2x plus 20 equals 22. Right, I just simplify. We subtract 20 from both sides. Once we get to an equation like this, we should know how to solve this, right? 2x equals 2, so we're going to get x equals 1. So here, I know x is 1, y is 5. I'm going to write that as an ordered pair. And this, x is 1, y is 5, is the solution to this system, these two equations. X is 1, y is 5 makes both of these equations true. It's the only number that makes them both true. Okay, so we're going to move on here to our first problem where we have to multiply by something other than -1. So, we're looking at this system right here. I'm going to look at both variables. I'm going to look at x first. I have 5x and 3x. There is no number I can multiply 3 by, no whole number, no integer that I can multiply 3 by. I could multiply it by a fraction, 5 over 3, and that would make it 5. But that would make my equation really messy. So I can't multiply 3 by something to make it equal to, or make it so it would cancel 5 out. So I'm going to move on to y. Can I multiply y by something to make it so it'll cancel this out? I sure can. What if I multiplied this whole equation by -2? -2. So what that's going to look like is we're going to have 5x minus 2y equals 4, and we're going to have 3x, oops, sorry, I have to multiply it by -2. -6x, -2 times 3x is -6x, plus 2y equals -18. -6x plus 2y equals -18. I multiplied -2, 3x, -2 times y, and -2 times 9. Now that's step 1. Now I add right down the line. I know that my -2y plus 2y cancels out. 5x plus -6x is -x equals -14. I think this one has some really weird high numbers if I remember correctly. -x equals -14. That means x equals 14. Now I have to pick either equation. I'm going to pick the bottom one just for fun. 3x minus 14 equals, 3 times 14 equals 9. Times 14 minus y equals 9. 3 times 14 minus y equals 9. I took this first equation here and I put 14 where x goes. So now we have 3 times 14, 28, plus 14, 42, minus y equals 9. I'm going to subtract 42 from both sides. Negative y equals negative 33. Y equals 33. So x is 14. Y is 33. If we want to be sure about this, there's two things we can do. We can plug it back into the equation. You guys have to show all this work. You can plug it back into the equation, or we could pull up Desmos. So I'm going to right over here, write my equation. Let's find my equation. 5x minus 2y equals 4. And my second equation is 3x minus y equals 9. And if I zoom way out, lo and behold, they meet. Where do you think they meet? 14 and 33. So what that means is we did everything golden. We were perfect. X is 14, y is 33. We could put it into both these equations and solve mathematically. A fun, quick way to check is just graphing it to see, is my solution correct? That is when both of these equations are true, is at 14, 33. So we have a third kind of problem, and in this last problem, you can go back and copy that down for your homework if you were watching this. This problem right here is also on your homework. It's one of your 4 problems. Here, I'm going to look at x. Can I multiply 4x by anything and get it to cancel out? 4x or 3x, can I multiply x by something? No. 3x times 2, 3x times 1, it's not going to cancel it out. It's going to be bigger. You'd have to multiply it by a fraction to get it to cancel out. 4/3, in fact. This one right here, I can't multiply it by anything either to get it to cancel out. Does that make sense? On the last problem here, I could multiply this by -2 and it would just cancel out. I can't multiply 3x by something, by a whole number, an integer, to make it be equal to or the opposite of 4x. I can't multiply 3y by an integer to make it the opposite of 4y. Here I'm going to have to multiply both of my systems. I'm going to multiply this by 3 and this by, I'm going to multiply by 3 up here and 4 on the bottom. -4, because I want to make these opposites. It doesn't matter which one you do by negative, but you have to do one of them by negative so that they'll be opposites. We want them to eliminate, right? So let me just do a quick check in my head. 3 times 4x is going to be 12x. -4 times 3x is going to be -12x. 12x plus -12x is 0. So if I multiply both equations by that, I just did a quick check in my head that that is going to make it eliminate one variable. So let's write the first equation. We said it's going to be 12x plus 3 times 3y is 9y equals 27. Let's make sure I have an x there, right? And the second equation, -4 times 3x is -12x plus minus 16y equals -48. Now, that's step number 1. Step 1 is the most difficult part for some people, because the second step's pretty easy. Now I just draw my line here, here, and here. and I add 12x when negative 12x to 0. 9y minus 16y is negative 7y equals 27 minus 48 is negative 21. Negative 7y equals negative 21. I'm going to divide both sides by negative 7 and get y equals 3. So that is my answer for y. Now there's one last thing we have to do, right? I have to say, so 4x plus 3 times 3. I'm substituting. So I've added the equations together and I solved for the variable that was left. Now I'm going to substitute that variable, this 3, into my top equation right here where y goes. 4x plus 3y times 3 equals 9. Four x plus 9 equals 9. X, 4x equals 0. So if 4x is 0, then x equals 0. So my solution is 0, x is 0, y is 3. Let's just real quick go back into Desmos. 4x plus 3y equals 9. Four x plus 3y equals 9. 3x plus 4y equals 12. They meet at 0, 3. And that is exactly what we said it would be, 0 and 3. So we know that that's correct. That is when the graphs meet. That is the two numbers, the x and y value, that make both equations true at the same time. That's our goal. And this is how we find them using elimination, these 4 short steps. The PowerPoint is going to be available in the agenda. If you need to look at these steps or anything as you're going, email me if you have any questions. Thank you very much and have a great day.